Hi, I'm Adam Porter, and this is Programming Mobile Applications for Android Handheld Systems.
Today, we're going to talk about the 4 fundamental building blocks from which all Android applications are built. These building blocks are implemented as Java classes. And the first of these building blocks is the activity class. Now that's the main class that users see when they run an application. Activities are designed to provide a graphical user interface, or a GUI, to the user, and this enables users to give and receive information to and from an application. The remaining 3 components work behind the scenes, so they don't have user interfaces. And these components include services for supporting long-running or in-the-background operations, broadcast receivers that listen for and respond to events that happen on a device, and content providers, which allow multiple applications to store and share data. Applications are typically created from multiple collaborating components, which Android starts up and runs as necessary. And each of these components serves a different purpose in the Android ecosystem, and therefore has its own entry point and its own APIs. Let's take a look at each of these components one at a time. First, let's talk about the activity class. As I said earlier, this class is designed to present a graphical user interface to the user and to capture the user's interaction through that interface. As a general rule of thumb, an activity should support a single, focused thing that the user can do. A single thing like dialing a phone number or entering contact information for a single person, and so on. Now, of course, as device screens, especially those on tablets, get larger and larger, what we mean by a single focused thing that the user can do is, of course, bound to change. Now, as an example of an activity, let's take a look at the phone dialer application. Here I'll show you the phone application running on an actual device. You'll remember from earlier lessons that the phone application can open a user interface with multiple tabs, one for a phone dialer, one for the call log, and one for a contact list. In Android 4.2, this application's source code is actually part of the contacts application, and it's written in a file called dialtaxactivity.java. Here, I'll open that file. As you can see, the dialtaxactivity class is a subclass of activity. And the comments here explain that this activity is supposed to display a tab containing the phone dialer, the call log, and the contacts list that I mentioned earlier. Let me pause here and give you a chance to explore this source code for yourself. The next component is the service class. Unlike activities, services run in the background, so there's no need for services to have user interfaces. Instead, services have 2 main purposes. One, they can perform long-running operations, typically away from the main UI thread. And 2, they provide a way for different processes to request operations and share data. Now, for an example of a service, let's take a look at the music application. So here I'll show you the music application running on a device. As you can see, the music application has a number of different user interface screens that show, for example, your music, showing the songs performed by a single artist, letting you select one song by that artist, and finally letting you play that one song. Now, if you start playing a song, however, and then decide to back up and see what other songs that artist has, or if you want to do something totally different, like check your email, you probably don't want the music to stop playing. So Android handles this by using a service to play the music. Now here I'll go to the music application and open the media playback service.java file. As you can see, the media playback service is a subclass of service, and the comments explain that this service allows the music to keep playing even if the user switches between different activities. And again, let me pause here and give you a chance to explore this source code for yourself. The next component is broadcast receiver. Broadcast receivers listen for and respond to events. And essentially, they play the role of the subscriber in the publish-subscribe pattern. In Android, events are represented by the intent class, which we'll talk about more in later classes. Publishers create these intents and then broadcast them using a method like the context class's sendBroadcast. Now, once broadcast, these intents are then routed to the broadcast receivers that have subscribed to or registered for those specific intents, at which point they can respond to the event. Now, the messaging application is one example application that makes use of broadcast receivers. Let's take a look at that application. So let's imagine that somewhere out there in the world, someone decides that they want to send me an SMS message. That SMS message will be created and sent and will flow through the telephone network and eventually arrive at my phone. And when it does, Android will put a notification icon in the notification bar to let me know that an SMS message has arrived for me. Now, of course, you can't know exactly when you're going to receive such a message. So Android has some software that just sits and waits for SMS messages to arrive. And when they do, that software broadcasts an SMS_received intent. And there is another broadcast receiver that is listening for that intent. And that broadcast receiver will eventually receive the intent and will then start up a service that will download and store the incoming SMS message. Now here I'll go to the MMS application and open one of its broadcast receivers, smsReceiver.java. As you can see, the SMS receiver class is a subclass of broadcast receiver. And the comments explain that this broadcast receiver hands off the incoming SMS message to a service which takes care of the downloading and storage of the message. Now once more, let's pause here and explore the source code for yourself. The last component is Content Provider. Content Provider allows applications to store and share data. Content providers use a database-style interface, but they're more than just databases. For example, content providers will handle the low-level details of inter-process communication so that applications running in separate processes can communicate and exchange data safely and easily. The browser application is one example of an application that uses content providers. So here I'll start the browser application. If I click on the icon next to the address bar, the browser opens a list of bookmarks or saved addresses for websites that I might want to access quickly in the future. When a user adds one of these bookmarks, the browser application stores it in a content provider. Let's open the browser application source code and take a look at the browserprovider.java file. As you can see, the browser provider is a subclass of content provider. And if we nose around a bit in the source code, you can see some suggestions that there's a database table called bookmarks, which is used for storing the bookmarks that the user adds. Now I'll pause again here and let you explore this source code for yourself. In our last class, we looked at the Hello Android application. That simple application involved just a single activity. Today, however, we're going to look at a more complex application, in this case comprised of two activities. And of course, once you know how to use two activities, adding a third and a fourth and so on will just be more of the same. This application is called Map Location, and one of its activities allows the user to enter a postal address. That activity also provides a button that the user can press once he or she has entered that address. And pressing that button will then start up a second activity, Google Maps, that presents a map centered on the address that the user just entered. Let's take a look. Now this graphic depicts the process of writing and building Android applications. First, you create the source code and the non-source code resources that make up your application. Next, tools compile your source code and prepare your resources. The output of this step is an Android package or APK, which corresponds to your application's executable. Next, the APK is digitally signed to identify you as its developer. And finally, the APK is installed on a device or emulator and run. As a developer, your participation in the build process will usually involve the following 4 steps: defining resources, implementing the application classes, packaging the application, and installing and running the application, in particular for testing and debugging. Step 1 is defining your application's resources. As I've said before, Android applications are more than just source code. They include non-source code entities as well, things like layout files, strings, images, menus, animations, and much more. And managing resources separately from the application has several benefits, one of which is that you can easily alter those resources without having to change or recompile your application source code in any way. One common resource type is strings. In Android, there are 3 types of string resources: individual strings, arrays of strings, and plurals. Now, I think strings and arrays of strings are pretty self-explanatory. Let's talk about plurals. Plurals are basically string arrays that can be used to choose specific strings that are associated with certain quantities, such as 1 book or 2 books. And the strings are typically stored in an XML file in the res/values directory of your application. And the format is an XML string tag containing a name attribute and then containing the actual string itself. And that actual string can include formatting and styling information, things like HTML tags, for example. Finally, other resource files can refer to the strings that you've defined as &string/string name. In Java code, you can also access these strings, but this time you do it as r.string.string name. So here we are again in Eclipse. I've defined some strings for the Mapplication application. Let's open the strings.xml file in the res/values directory. This file shows 2 strings, show_map_string with the value showMap, and location_string with the value enterLocation. Now I've also defined a second strings.xml file, this time for the Italian language. And it's in the res/values-it directory. And that IT prefix in the directory name is what tells Android that this is the string file for the Italian language. Now if we look at that file, we'll see the same 2 strings, show_map_string and location_string, but this time their values are Italian words rather than English words. In the example I just showed, if your default language is Italian, then location string will have the value digita l'indirizzo. Otherwise, it'll have the value enter location. Let's see that in action. Now I'm going to run map location twice. The phone on the left uses English as its default language, while the phone on the right uses Italian as its default language. Now as you can see, although both phones are using the same exact source code, the phone on the left displays English strings, while the phone on the right displays Italian strings.